Good day everyone. Today, we will discuss the supremum and the infimum value of a set. So our learning objective today is to define the supremum value and the infimum value. The next one is to solve for the supremum and the infimum value of a set.
Okay, now let us define the two terms. To define these two terms, let us consider S is a set of real numbers. Okay, the first term, the supremum value. It is also known as the least upper bound of set S. Again, set S is set of real numbers. It can be denoted as supremum of S is equal to the supremum value M, where M is greater than or equal to X, where X is an element of set S. Next is the infimum. It is also known as the greatest lower bound of set S. It can be denoted as infimum of set S is equal to the infimum value M, where M is less than or equal to X, such that X is an element of set S, opposite with the supremum. Okay, to determine the supremum and the infimum value, you must consider this statement: the supremum and the infimum value may or may not belong to set S. Okay, let's have an example. Determine the supremum and the infimum of set S is equal to X such that X is equal to the quantity of 1 plus negative 1 raised to n times n squared, where n is greater than or equal to 1, or n is natural numbers. The first step, look for the possible values of n that will satisfy to X is equal to the quantity of 1 plus negative 1 raised to n times n squared. Okay. So n, the values for n are, start with 1, 2, 3, 4, and so on. So if n is equal to 1, the value of X is negative 1. While if we're going to substitute the value of n, where n is equal to 2, the value of X is equal to 15 over 2. When we substitute the value of n is equal to 3, the value of X is equal to negative 1/3. If n is equal to 4, the value of X is 127 over 4. Okay. So, and so on, where n is equal to n, so X is equal to the quantity of 1 plus the quantity of negative 1 raised to n times n squared. Step 2, rewrite these elements into interval notation form. So, it is set S is equal to negative 1 is included to set. So, close interval up to 0, union 0, close interval to 0, up to positive infinity. Okay. So, step 3, identify the supremum and the infimum value in the interval notation. Okay, as you can see, set S, the element of set S, continues increasing. So, therefore, it is unbounded above, where the supremum value of X is equal to positive infinity. And it is limit into negative 1. So, the infimum value of S is equal to negative